Hello everyone, today I'll introduce my paper, Seeing What You Said, Talking Face Generation guided by a lip reading expert. My paper session is Wednesday PM 2:20. For talking face generation, previous studies has realized the importance of lip-speech synchronization and visual quality. For example, synthesized image may be blurred and the lip movement may have a delay with corresponding audio. However, they hardly focus on the content of the lip movements, namely the reading intelligibility of spoken words, which is an important aspect of generation quality. Therefore, our paper aims to improve reading intelligibility by leveraging a lip reading expert. A question need to be classified before implementation is that whether visual quality and lip speech synchronization are the same with reading intelligibility. The answer is definitely not. Take lip speech synchronization as an example. Maggot effect is from human speech perception and illustrates that when audio and visual stimuli are synchronized but not consistent, human may recognize them as the audio content, video content, or other fields content. Lip reading is hard even for humans. In a speech experiment, 4 people with equal gender distribution are invited to read the lip movement. However, the average error rate is as high as 47%. A reliable lip reading model relies on a great amount of data. Therefore, we employ AV Hubert, a self-supervised method which has yielded SOTA performance in lip reading, speech recognition, and audiovisual speech recognition. In the self-supervised stage, clustering classes handcraft audio feature or learned audiovisual feature as studio label. We can use the studio label to train visual front end and share the transformer encoder for both audio and visual modality. After that, we first construct a lip reading expert with the pre-trained transformer encoder and decoder, and then we fine-tune it with text annotation. Another novelty is using the pre-trained transformer encoder to extract audio context features. The transformer encoder is pre-trained synchronously with lip reading expert, and it can consider global temporal dependency across the entire audio utterance. And previous study extract audio embedding from only 0.2 audio segment. Here is the diagram of a proposed network, namely TalkLip. The goal of the network is synthesize images by triplets of pose image, identity image, and a speech. To improve reading intelligibility, we use the lip reading expert to penalize incorrect lip movement in synthesized images. And contrastive learning is conducted between the audio embedding and output features of lip reading experts encoder. And let me summarize my contribution. We tackle the reading intelligibility problem of the talking face generation by leveraging a lip reading expert. To enhance lip speech synchronization, we proposed a novel contrastive learning strategy, which is assisted by a lip reading expert. And we also employ a transformer encoder, which is trained synchronally with the lip reading expert, and it can consider global temporal dependency across the entire audio utterance. And we also propose a new strategy to evaluate reading intelligibility and make the benchmark code publicly available. And extensive experiment shows that a proposed method achieves SOTA reading intelligibility and lip speech synchronization. We train a TalkLip under LS2 training set and evaluated in LS2 and LRW. As LS2 is the data set for continuous audiovisual speech recognition, we use the word error rate to evaluate reading intelligibility, and LRW is a data set of audiovisual word classification, so we use the classification accuracy to evaluate it. We can prove the effectiveness of a contribution by quantitative result. We can see that with contrastive learning, no matter based on talk leap with local or global audio embedding, deep speech synchronization, and lip reading intelligibility is improved. And if we use the global audio embedding, the performance of lip speech synchronization and reading intelligibility can be improved. Overall, talk lip achieves the SOTA lip speech synchronization and reading intelligibility. From qualitative result, it's observed that synthesized images are closer to the ground truth. With the global audio embedding, namely G, talk lip can synthesize fuller lip movement. And if we train talk lip without contrastive learning, lip movement may be ahead of audio as this picture. You can see this picture is a little bit ahead of the audio. We also visualize audio embedding. We can see with the global audio embedding and contrastive learning, audio embedding is more distinguishable. Let's see a demo video.
What's the best thing about the Royal Highland Show?
Let's play each video separately.
What's the best thing about the Royal Highland Show? What's the best thing about the Royal Highland Show? What's the best thing about the Royal Highland Show?
We can see lip movement in our videos are full and express the same speech contents.
What's the best thing about the Royal Highland Show?
Let me make a conclusion. A lip reading expert is efficient to improve reading intelligibility, and contrastive learning and transformer encoder both can improve reading intelligibility and lip speech synchronization. Extensive experiments prove that our proposal achieves SOTA reading intelligibility and lip speech synchronization. Thanks for your attention.